we'll learn how to implement stack using linked list. Okay. So we have seen what is stack and how to implement stack operations using arrays, right? So now we'll see how to implement this using the linked list. What is meant by linked list? It has a head pointer, right? And also nodes. For single linked list, node has two parts. First one is data part. The next one is next address, right? So here for stack also there is an important concept called top. Okay. So in case if there are no elements, top remains -1. Okay. So all these concepts are included in stack using linked list. Okay. Now let's see how you perform operations. Now initially there are no elements. So top equals to -1. Top equals to -1. Okay. So if you want to insert elements, you have to see if there is space or not. Right. But here you won't be checking like what is linked list. Linked list is used for dynamic memory allocation. Okay. So you need not allocate memory before itself. Okay. Say for example, this is taking data part is taking 2 bytes. My next address is also taking 2 bytes. Total 4 bytes. So each time when I try to insert elements, each time when I try to push elements into stack, okay, what are my elements here? Nodes. Each time when I try to push nodes into the stack, I should have 4 bytes of memory. That's enough. First time 4 bytes. In case second time if I want to insert, I'll insert 4 bytes like that. Okay. So first my element is, I want to insert 20 and the space is available at 200th location in case there are no elements here. So I will write null. Okay, first I have to create node, then add it into queue. Now push. Okay, now I have pushed. So what is my data? 20. Next part is null. So address is 200. Okay, now top value is not being incremented like the others. Okay, top points to my first entered node address. Top. This is top. So top is containing. So now top is containing the address of inserted new node. Okay, what is the address of this node? 200. So top equals to 200. Okay, now I try to add one more element. My element is sum 96. It is stored at location of 960 and while creation it is null. So you have to insert it. So it is 96 and we haven't connected yet. So it is placed at location 960. Okay. Now what you'll do is this element and this element got a connection. Okay. So 96 next address is storing 200. Okay. This is my first element. This is my second element. Now top always points to my newly inserted node. Right? Top is changed to 960. Just like normal insertion in single linked list, but it follows insertion at head only. What happens if you insert at head position? This will be head. This would be my head. Now, in case if I add one more element, the new element will be pointing to the head. Right? So, if I try to add one more element, my element is 31. Is stored at location 300. It was null. Okay, next part is null. So I've inserted this also. Okay. So I've connected. Now what is its address? 300. So 31's next part is containing 96 address. That is 960. Now top is pointing to this element. Okay. So now top is 300. Okay. So I'll show you how this is represented in normal linked list. Okay. So if my first node is 31, 300, second node is 96. Okay. This follows just like normal stack operation. What is stack rule? Last in, first out. So just like that, the element which is inserted last will be out first. The elements or the nodes which are being pushed first will be coming out last. The elements or nodes which are being pushed at last will be coming out or popped first. So this was the last inserted element. So this is the first element to get popped. Okay. Now this is how representation is done. Now top, this is top. Initially when it was only one element, top is pointing over here. After adding second element here, then here. So now you perform stack using insertion operation at head position only. So the reason for taking only head position is, say for example, I have asked you to insert element at end. Okay. So if I ask you to insert an element on it, each time I have to traverse for adding this element 1, 2. I have to do 2 traversals. Again, if there are 5 elements, I have to do 5 traversals. But in case if I want to add at the head position, I just need head value. I will change my head value. I will change the, added elements next address. Right? So this is the reason why I will consider insertion at head operation. Okay? For stack using linked list. Right? Now, let us perform pop operation on stack using linked list. Okay? Now, what is my pop? General stack rule, last in, first out. The element which is inserted last or the element which is pushed last will be popped first. Okay, this should be popped. Then, which element does the top represent right now after deletion? It should represent here. But we are not doing any top decrement operations. Okay, we cannot change addresses like that. We cannot perform increment or decrement operations on addresses. So now what we'll do? Now, after deleting this element, we'll consider this next element. Okay, this next pointer. Now, I will point my top to that element. Okay, once we'll see how it is done. So first pop operation. What is top? This is my top. This is going to be deleted. What is the next element to my top element? What is the next pointer to my top element? 960. Where is 960? It will be pointing to 960. Right? Now my top is 960. Now I have deleted this. Right? Now I try to pop element one more time. So after deletion, my top will be pointing to the deleted elements next. What is my next element? My deleted elements next part. What is my next pointer? 200. Where is 200? 200. Where is 200? Over here. So my top will be pointing to 200. Right? So after this, I try to delete this element. Now my top does not point to any element. It becomes -1. So this is how you pop elements from the stack using linked list.